Hello, today we are covering 6.2, multiply and divide radical expressions. You guys will be able to do just that, multiply and divide radical expressions. So before we get started, I'm going to draw out a little picture over here to help us with some vocab. Be helpful next week too. We have something called an index. I've been calling that the root. I'll probably keep calling that the root. But it's technically called the index, as well as the number underneath or letter is called the radicand. And this is the radical symbol. Oops. Okay? So now that we know what those are called, we can talk about them. So, our multiplication property when multiplying radical expressions means that we need to have the indexes be the same thing. In this general form, they're both n. That means they're the same number. And then you can multiply the numbers underneath the radical symbol together. The radicands can just be multiplied, so you have a times b all within that radical symbol, okay? So the first example, part A, we need to simplify. The thing is, what we should check for is if we can even do that. Right now we have a cubed root and a squared root. The indexes do not match up, meaning we cannot even simplify this. So we can't simplify. Because the indexes are different. And I usually call those the roots. Those are different. Okay? This next one, though, we can, because the indexes are the same. So all you do is you multiply -4 times -2. And you get the cubed root of -8. Now we need to pay attention to what is underneath this, because if you can simplify our radical, whether it's a square root, cubed root, fourth root, you should try. So I'm going to take my prime factors. Maybe by now you've noticed that 8 is a perfect cube. Oh, watch out, got to have a negative on one of these. So you end up getting the cubed root of -2 times 2 times 2. Those group up. And we get the answer being just -2 as our solution. Okay? So this next example, simplify radical expressions, is really just review from 6.1. I'm going to go through these pretty quick, and you can follow along, pause me if you need to try and check yourself. So I'm going to split up the number first, do my my primes, I should say. Oops, 2 is not 1. So my cubed root, so I need groups of 3. Pull them to the front. And then I am left with 3x cubed root of 2x squared as my solution. Okay? Same thing as we did yesterday. Hopefully it's not too hard. We're getting the hang of it. It's just kind of a tedious, long process. Part B, gonna do the same thing. So I found my perfect primes, or my primes. Can write out my x values. have 7x's. I need to group them by 3's because we're talking about a cubed root. So then I pull out what is in a group, and what is not in a group stays under. So I have 2 times 2 is 4. X squared, because we have x times x from the other groups, cubed root of 2x remaining. And we're done. So that is to review for step 3, simplify a product. Now to simplify a product, you just multiply as long as these indexes are the same, you multiply what is under. So I'm going to show out a couple extra steps. You could do some of these in your head. I have 72x cubed y squared times 10x y cubed. I just multiply my numbers, so I get 720. And when you multiply variables with exponents, you actually just add the exponents. So I get x to the 4th, y to the 5th. From here, I can solve using my factor tree, although I'm going to go about it a little different way this time. I'm going to start with a 5 instead of a 2. Oh, sorry, 720, not 72. So I know that's divisible by 5. I'm going to start there, and I actually end up getting 144. And I know 144 is a perfect square. So for my numbers, instead of doing the factor tree out of the way, I found my biggest perfect square and reduced this to 12 square root 5. Okay. Now I need to reduce my exponents, my variables with my exponents. And I know it's a square root, so I could do the whole, write them all out, find the groups. There is a shorter way we learned on our previous lesson, that if this is a squared, just divide. So I'm going to do it in a different color. And over here, divide the exponent by what the index is and however many there are. If it comes out even, you end up pulling out an x squared over to the outside. If it does not come out even, like y to the 5th, pretend you're doing a long division. You have 2 times that it goes into it with a remainder of 1. So you will have y squared pulled out from this guy and a 1y left on the inside. So this is kind of a messed up way of writing it. But once you put it all together, you have 12x squared y squared square root 5y as your solution. If you're having trouble seeing what I mean here, you can write out all of them totally fine until you get to like 30 y's that you have to write up. Then you group them. Notice you end up getting the same thing. Really, division is just kind of like grouping like we're doing here, but without the picture. Okay? Next one's similar. I'm going to go ahead and do that one. You can follow along. So I have one part so far. This is going to be part of my answer. I'm going to do another part. Now this is a squared, so I'm going to see if I need any remainders. So this will be on the outside. This is x cubed, so x cubed goes on the outside here. I know this is y. Oops, sorry. This should be a 2 here. Getting ahead of myself. Y cubed with 1y left over. So y cubed is also on the outside with a y left over. so I can rewrite this 15x cubed y cubed square root 7y. Now you'll notice these are kind of hard to write out and keep everything straight. I almost do too many steps in my head maybe, which you are perfectly welcome to do those steps in your head too. I just did my best to write it out for you so you can see where things go and where things come from. And then we have the division property for radical expressions. Now, I would say division is actually easier than multiplication in this case. As long as our indexes match up again, all you have to do is combine your pieces. So, let's try one. These guys have both index of 2, so we can put them all in the same radical. And then we can reduce these. Now, it's just as simple as taking 18 divided by 2, we get 9. And then recall, if we're adding the exponents when we multiply, we need to subtract them when we divide. Now, it'd be nice if we were done there, but we have to make sure that these are not reducible as well. And we know 9 is actually a perfect square, so that reduces to 3. And the square root of x squared actually just reduces down to x. So our solution is actually just 3x. Okay? A couple more. Once again, the indexes are the same. They're both 3, so we can put them all inside like so. 162 divided by 3 is 54, and then y to the 5th over y to the 2nd reduces to y to the cubed, and we have the cubed root here. So the cubed root of 54 is not a perfect cube. I'm going to go ahead and separate this out to 2 and 27. Now, we know 27 is a perfect cube, or hopefully you know that. So we can go ahead and say that the cubed root of 27 is 3. That will come out to the outside. We can't reduce the cubed root of 2, so that'll stay on the inside. And then the cubed root of y cubed is actually just y. They also cancel out, like the previous squared problem. So those cancel out, and you're left with just y. And lastly of this type, once again the indexes match, so we can say 50x to the 6th over 2x to the 4th. We have square roots again. 50 divided by 2 is 25. X to the 6th over x to the 4th reduces to x to the 2nd because you subtract your exponents. The square root of 25 is 5. The square root of x squared is x, and you have finished that one. Okay? And then we have one more type of problems. This first one is actually pretty easy, and then the following ones we kind of mix it up a little bit. So the first one, you can simply rationalize the denominator by multiplying both the numerator and the denominator by the square root of 8x. This works for square root type problems. If you get cubed root or fourth root, we have to work with those differently. So now, since the indexes match, we can actually say that the square root of 8x times the square root of 8x is actually just equal to 8x. These guys get rid of each other, you're left with just what's inside. So 8x is in our denominator now. And then because the indexes match in the numerator, you can just multiply 5 times 8x and get 40x, all within the square root. 40 does reduce. We have 4 and we have 10. That 4 is actually a perfect square. So we know this just comes down to 2 root 10. So we have 2 root 10. Don't forget the x inside with the 10. Maybe I should put this up here as well. There we go. And then that is all over 8x. Now make sure you can't reduce outside of the radical in the numerator and denominator. In this case, you can. They are both divisible by 2. So your solution ends up being the square root of 10x over 4x. And that is it. All right, so here's where it gets a little more confusing. B and C are slightly different. To rationalize a cubed root, you actually need to have everything inside be a perfect cube to be able to cancel it out of the denominator. So it'd have to look something like this to be able to cancel it out. So what we need to do is actually figure out what we need to multiply both the numerator and the denominator by so that the denominator will equal this. So I need a question mark thing in there. Basically, we have 5 to the first power now. We need a 5 to the second power. And we have a y to the second power right now. We need to multiply by another y to be able to rationalize the denominator. Now there's one other big part here that I hadn't written out yet. This is actually a cubed root still. So we just figured out what we need to multiply both the numerator and denominator by making it equivalent to this in the denominator eventually. So we need to take the cubed root of 5 squared times y in both the numerator and denominator. This will get our denominator to equal what we had set up right here. The cubed root of 5 cubed y cubed over, and then go ahead and just multiply things, the cubed root of, well, 7 times 5 is 175. And then x times y, just xy. And then we finish simplifying the denominator. We end up getting that the cubed root of 175xy over 5y as our solution. So this whole set it up and make it become a cubed inside of that cubed root is a little bit different than what we've been doing, but it's not really that hard. You just have to make up for what's missing. Okay. And then lastly, we have another cubed root one. He's going to work very similar. We have to figure out what we need to multiply both the numerator and the denominator by to make this become a denominator of cubed root of 2 cubed. Okay, so all I need to do is, because I have a 2 to the first power, I need to multiply both the numerator and denominator by a 2 to the second power. I end up getting, so the cubed root of 2 times the cubed root of 2 squared is equal to the cubed root of 8, as we have here. These are all equivalent. And then the cubed root of x times the cubed root of 2 to the second power is the cubed root of 4x. You just carry this over, cubed root of 4x. And the cubed root of 8 is actually just 2, so our final solution ends up being the cubed root of 4x over 2. And that is it for that one. Okay? So, that is all I have for you today. That's 6.3. Have a great afternoon.